Now let us see how our iterative in-order traversal method works on our example tree. So let's draw the tree that we have been using throughout these examples. So I have 10 as the root node, and then on the left I have 20, and to the left of 20 I have 60, and then right I have 50, and then the right of 10 I have 30, and then I have 40, and then I have 70. Okay, so let's start executing our iterative in order traversal with call to in order iterative with address of node that contains the value 10. Okay, so now we'll keep track of our variables and our stack. So I'll say that my current is now equal to, when I come inside, it is going to be the address of node that contains 10. That's where I have started. So my current is going to be 10. Again, remember, this is the address of the node we are talking about, but for the sake of simplicity we are simply writing the value. So now I've started and now I create a new stack and I need the node count 1 2 3 4 5 6 7. So I'm going to create a stack with 7 slots. Okay, 1 2 3 4 5 6, and I need one more, which is 7, indexed from 0 1 2 3 4 5 6. And now I'm going to ask question, is my stack empty? Yes, my stack is empty. Okay, so not stack empty is going to be false, and this is OR operation, and for this whole condition to be true, at least one part of the condition needs to be true, but this part of the condition is currently false. But then I ask question, is my current pointing to null? My current is not pointing to null, so this OR condition comes out to be true, and then I enter inside. And then what I am doing is, while I can find a left branch, I keep on going to left, but I remember every node on the path by pushing it to the stack. So what will happen is, first thing I'm going to push 10 onto the stack, and then my current will become 20, and I come back and current is not null, so I'm going to push 20 onto the stack, and then my current will become current dot left, so it will be 60, and then I will ask question, is my current null? It's not, so I'll push 60 onto the stack and my current will become null. Okay, so that's when I have reached the leftmost branch in my current subtree, and now this while loop will finish. Okay, because my current is null. So now I will pop a node from my stack into current, so 60 is gone, and now my current becomes not null, but it becomes 60, and then I will print. So let's keep track of our output here. So my output is now 60. Okay, so I perform this action. So let's say that our action is just print current dot value. So I printed 60, and now I'll be just happy to move to the right branch of 60. 60 is a leaf node. There is nothing on the right, so 60 dot right will be null. So my current will again become null, and I have reached end of this while loop. And in our pseudocode we should be having one more closing braces. I keep on forgetting that somehow. Okay, so now let's come back. We reached here, so we go back to the beginning of loop and ask question, is our stack empty? Well, our stack is not empty. So negation of that is going to be true. So we don't care about what is the current value of null. So we come inside and ask question, is our current null? Well, it is null. Okay. In that case, there is nothing to do in this while loop, and we just have to pop a node from the stack, and what do we get back? We get back 20, and this is the indication that we are done with the traversal of the leftmost subtree, left subtree of the node that we just popped. We remember this node in the stack so that we can go and do the traversal of the left subtree, and currently we are done doing that. So now I am going to pop a node, so my current now will be 20, and I'm going to print the value of the contents of my current, so I'll get 20 here, and then I will move on with the right node of 20, which is 50. So now my current becomes 50, and I come back to the beginning of this while loop. I ask question, is my stack empty? My stack is not empty. So what should I do? Okay. Oh, I forgot to remove 20, right, from the stack. So my stack is not empty. So I don't care about the second condition right now, because at least one of them needs to be true. So I come inside my while loop and ask question, is my current null? It's not null, it is pointing to 20. In that case, now I have to go and do the in-order traversal for the left subtree. And for doing that, I have to remember this node 50. So that's why I have this while loop. I have to remember not just node 50, but every node along the leftmost branch. Okay. So I will go and push 50 onto the stack. So here is my 50, and then my current becomes current dot left. 50 is a leaf node, there is nothing on the left, so my current again becomes null. When I come out of this loop, I know that my current is null. Okay, so in that case, I'm going to pop a node, and now I take out 50 from the stack, so current becomes again 50. And now I perform the node specific action, because I know that I'm done with the traversal of the leftmost left subtree. So my output will now have 50, and then I proceed with the right subtree of 50. But 50 is a leaf node, so my current will become a null node again, and I come back to the beginning of my while loop. I ask question, is my stack empty? It is not, it has single element. So let's not worry about the second condition, because there is an or between. I come and ask question, is my current null? My current is null. In that case, I'll skip this while loop, and I'll pop a node from my stack, and I'll get back my 10. And when I get back my 10, what does it indicate? It indicates that I'm done with the in-order traversal of my left subtree. That's good, which means that now I have to perform the node specific action. So I'm going to print 10, and then I will simply switch to, so I have to pop 10, right? Yes, I forgot that. Now I'll move to the right of 10, which means that my current will become now 30. Okay, and I come back to the beginning of this loop, and this is the place where I again see my stack is empty. Do you remember we had the stack empty when we started the traversal? When we finished the traversal of left subtree of our root, even in that case, what is going to happen is we are going to pop out the root node, and our stack is going to be empty, and current will be the right child of our root. So currently my stack is empty, so negation of that is going to be false. So now I have to care about the second condition. Is my current null? My current is not null, it is pointing to 30. Okay, fine. So what should I do? Again, I should start with the in-order traversal of left subtree. So I have to remember the current node 30. So I push it onto the stack. So I have 30 onto the stack, and then I move to the left, and then I have 40. so even 40 goes onto the stack, and then I move to the left, so 70 goes onto the stack, and then I move to the left of 70, but 70 is a leaf node, so I get a null pointer, so I break out of this while loop. And now essentially what I have done is I have saved every single node on this leftmost branch of the current subtree that I am exploring. And then the next thing that I have to do is pop an element, so I'll pop out, so current was 30, and then it became eventually 40, and then it became 70, and then it became null, okay, through the execution of this while loop which is inside, okay. And now we finished that, and now we are popping an element from the stack, so stack will return us 70, okay. So instead of null I'll get back 70, and I have to perform node specific action because this indicates that I am done with the traversal of the left subtree of 70. So I will now add 70 to my output, and then the next thing to do is make current as right child of current, so it will again become null, and I come back to the beginning of my loop, the outer while loop, and now I know that my stack is not empty, so don't worry about the second part. We come inside and ask question, is my current null? Yes, it is null. In that case I need to pop an element from the stack and I'll get back my 40, okay. So now my current is 40, and this indicates that I am done with the traversal of left subtree of 40. Time to perform the node specific action, which is just printing in this case. So I will print 40, and then what should I do? I should move to the right of 40, which is null. There is nothing to do here, okay. So I come back to the beginning of this while loop and I ask question, is my stack empty? It is not empty, there is still 30 out there. So I will enter my while loop. I will ask question, is my current null? It is null, so I'll skip this inner while loop and I'll ask question, oh, can I pop something from the stack? Yes, I can, and I'll get 30 from the stack. Once I get the 30, it means that I'm done with the traversal of left subtree of 30. Time to perform the node specific action for 30, which is just printing. So I'm going to print 30, and then move to the right of 30, which is, it's still null. So I come back to my outer while loop, ask question, if my stack is empty? Yes, my stack is empty. Negation of that is going to be false. So for this OR condition, first part is false. So I have to check for the second part, is my current null? My current is null. So we have reached a stage where there is nothing in the stack and I am pointing to a null pointer, which means that I have completed the in-order traversal of my binary tree. Okay, so that's how both these conditions are important. Okay, if I know that only the stack is empty but my current is not null, then I'm either starting my in-order traversal or I'm done with the left subtree of root and I have visited the root, and the only remaining thing is performing the in-order traversal for the right subtree of my root. And sometimes my stack will not be empty, but all I will have is just my current is null, and that is going to happen when you have the right subtree empty. Okay, so that's how both these conditions play an important role in iterative in-order traversal, and we can check if we get the same output as the recursive in-order traversal. So in case of recursive in-order traversal, our output was 60, 20, 50, 10, 70, 40, 30. So we get identical output as compared to the recursive in-order traversal. So yes, our output should be exactly the same because we are still doing the in-order traversal, but we have a different logic. But if you ask the question about time complexity, well, our time complexity is still going to be theta n, you might feel that oh, there are two nested while loops, so it might be quadratic, but that's not the case, because you can observe that onto the stack every node was pushed only once. Okay, no value appeared on the stack multiple times, so every node comes to the stack just once. So number of push operations are linear in terms of the number of nodes. So if this happens only theta n times, even this operation happens theta n times. So this while loop, if I count it across all the nodes of my tree, it contributes only theta n operations. Okay, so if I just remove this block from consideration, what remains is its popping of the values, which again happens theta n times, and we are assuming that the node specific action is constant time. So the total time complexity of this in order traversal performed in iterative manner is theta n. Where it differs from the recursive logic, it doesn't have any recursive calls. Okay, so that's the difference. But we are still using stacks. So recursion still uses stacks by using recursive calls. We are using explicit stack. That's the difference.